Hey guys, in this video we'll be coming up with an example and an exercise sum. Now first let us get into example 5. Here the question is, the shadow of a tower standing on a level ground is found to be 40 meters longer when the sun's altitude is 30 degree than when it is 60 degree, and we have to find the height of the tower. Now first let us draw a diagram. Let us consider this line to be the height tower, and this to be the ground, and the point from ground to the top, it is 30 degree when the sun's altitude is 30 degree, and this is when sun's altitude is 60 degree, and it is given that the shadow is 40 meter longer when it is 30 degree than the 60 degree. So this part will be 40 meter. Now let us name this A, B, C and D. Now we have to find the height of the tower, that is AB here. Now we can take this part as x. First let us consider triangle ABD. In triangle ABD we have BD and AB. So we can take BD first. BD is 40 plus x. And if we come to the triangle ABC, we have triangle ABC. We have tan 60 to be equal to AB by x. Now tan 60 is root 3, and AB we can take it as height, as it is the height of the tower. So h by x. Now if we bring this here, we will get x root 3 to be equal to height. Now coming to the ABD again, we have tan 30 to be equal to h by 40 plus x. Now we have the value of h to be x root 3, so x root 3 by 40 plus x. We have the value of tan 30 to be 1 by root 3. Now if we cross multiply, we get 40 plus x to be equal to x into root 3 into root 3. So root 3 into root 3 is 3. So we can take it as 3x. Now bringing this x here, we get 40 to be equal to 3x plus x will be minus x here. So 3x minus x is 2x. So 40 is equal to 2x, and if we bring this here, so 40 by 2 is equal to x. 40 by 2 is 20, as we know. So 20 is equal to x. This part is 20 meter then. Now coming to the height, we have that x root 3 is equal to height. We can substitute x there. So we will get 20 root 3 as the height of the tower. And that's it with this sum. Next we can get into the 8th sum in exercise 9.1. Now coming to the 8th question, we have a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree. Now let us take this as the pedestal and this as the statue. We can take a ground, and from the point it is 60 degree. And from the same point, the angle of elevation of the top of the pedestal is 45 degree. So from pedestal, it is 45 degree. And we have to find the height of the pedestal. We can take it as x. and the statue is 1.6 meter tall. Now we have to find the value of x here. First, let us name it A, B, C, and D. Now, in triangle ACD, we have AC to be equal to 1.6 meters. Sorry, 1.6 plus x. We have DC to be equal, we can take it as B. And now in triangle BCD, we get x by B, that is tan 45 is equal to x by B. And tan 45 is 1, so 1 is equal to x by B. If we bring this B here, we get B to be equal to x. And we can name it as equation 1. And now moving on to triangle ACD again, we get in triangle ACD, tan 60 is equal to AC by DC, so it is 1.6 plus x divided by B. Tan 60 is root 3, so 1.6 plus x. From 1, we can substitute that B is equal to x, so we can substitute x here. So bringing this here, we get x root 3 is equal to 1.6 plus x. Bringing this x here, we get x into root 3, x root 3 minus x is equal to 1.6. Taking x common, we get x into root 3 minus 1 is equal to 1.6. Bringing this again here, we get x is equal to 1.6 by root 3 minus 1. And if we rationalize, we get root 3 plus 1 by root 3 plus 1. And x is equal to 1.6 into root 3 plus 1. If we multiply this, we get it is in the form of a minus b into a plus b. So we can write it as a square minus b square. So we get root 3 the whole square minus 1 square, and we get 2. And if we cancel, we get x is equal to 0.8 into root 3 plus 1. And that's it for today. For more videos, do subscribe and like and share my videos. Bye.